Today we are going to talk about features. This is the next lecture we have in this course. And the outline for this lecture will be, first we will go through some of the basics of features, what features are and why we really need these features. Some of these aspects we have already covered in some of the past lectures, but I will try to briefly touch upon those. Then we will look into key points which are actually useful to extract some of these features. And then we will try to cover two classical approaches to extract features from images. The first one is histogram of oriented gradients. It's a very popular algorithm if you have to extract features from images. And the second one is SIFT features. It's called scale-invariant feature transform. So we're going to cover these two algorithms for feature extraction in classical category. And in one of the later lecture after this, we'll see like how we can actually extract these features from, again, images using deep learning approaches. Okay, so let's start. The first segment is we'll briefly cover the basics. And as I said, most of this we have already covered in the past. So I will try to quickly go over these. Now, the question is, what exactly is a feature? So if you think about this in computer vision, what we want is we will have some kind of visual information, or you can say like some data point. It could be an image, it could be like some video, or it could be like any other, like it could be like grayscale image or any other form of input, right? Which you have to analyze or which you have to use to make some kind of predictions. So given that input sample, what you have to do is, given a task, you have to perform that task, right? If it's classification, you will have to say, okay, which class category is present in this image. So we'll have different variations of problems. So to be able to successfully do that, to let's say do even classification, you need to represent that data sample in a compressed format. And that compressed format is called feature. So it won't be like the complete image itself. It will be like some kind of compressed format, which has like sufficient amount of information so that you can solve like a downstream task. Okay, for example, classification, those features will allow you to say, okay, which class category is present in this input image. It could be image, it could be in video. Okay, so those are called features, and these features could be handcrafted. So for example, if I'm saying we are trying to go through those classical approaches, so those approaches are kind of classical algorithms, and you can say like you are extracting handcrafted features, or these features could be learned. For example, when you train your neural networks, you are training that network on large amount of those data points, right? So whatever feature you extract, it's not handcrafted. You didn't design those features. Those kernels which were used to extract those features will be learned, right? So those are called learned features. Okay, so and at the end, we just need a function which will take that image as input and give you these set of features. And it depends like whether that function is like something which you have designed by hand or the function is something like which you have learned. So that's the distinction between these two. Okay, so handcrafted features, it's also called feature engineering. You might come around with this term as well. And learned features are automatically learned.